What if the biggest revolution in trust wasn't banks or governments, but computer code? Imagine yourself sending money, voting, proving you own something, all without a middleman. That's the exciting promise of blockchain. You've probably heard the word blockchain, especially with Bitcoin and crypto, but blockchain is much more than just digital money. In the next few minutes, I'll break down this technology step by step. By the end of this video, you'll understand what the blockchain is, how it actually works, and why so many people think it could change our digital world. Let's jump on in. So, what is the blockchain? At its heart, the blockchain is a special kind of digital record, a way to store information safely and openly. Think about it for a second. You might have used a spreadsheet to track your money. These contain records. They show transactions, who paid what to whom, and when. But blockchain takes this idea and makes it much more powerful. Now, imagine you have a shared notebook, but instead of just you writing in it, everyone has their own identical copy. And here's the key part. Entries can only be added, never erased or changed. These entries get grouped together into what we call blocks. Once a block is filled up with information and everyone agrees that it's correct, it gets linked to a growing chain of previous blocks. Each new block contains information and is effectively a special digital fingerprint, called a hash, of the block that came before it. This creates a chain where every piece links to the next one. You can kind of imagine it like a shared Microsoft document where everyone can see every change. Each change gets a permanent timestamp, and no one can go back and delete what was written before. Now, say you want to send $1,000 worth of Bitcoin to a friend. That transaction, along with others happening around the same time, get recorded into a new block. This block stores who sent the money, who received it, how much it was for, and when it happened. Once everyone agrees it's correct, this block gets permanently added to the chain. But what makes this record so different from a regular database? The answer is in who controls it. This brings us to the next key feature. There's no central control. In the systems we're used to, there's almost always one authority in charge, which we call centralization. With traditional money, your bank controls your bank records and they keep their database on their own computers. But the bank also decides when to charge you $35 for just being $2 overdrawn. That's a real magic trick. Blockchain flips this completely. Instead of living on one company's computers, a blockchain runs on a network of computers called nodes, spread all over the world, or in other words, it's decentralized. Each computer has a complete copy of the entire blockchain record, and they all work together to check new entries. Here's another way to picture it. Instead of one trusted accountant keeping financial records for a small town, imagine if every family in the town kept their own identical copy of the records. They regularly meet to compare notes and make sure everyone's books match exactly. If the accountant's books get lost or damaged, that's not good. But if every family has a copy, the system is much harder to break. This makes a blockchain very hard to shut down or trick. There's no central point to attack, no main computer to crash, and no single authority who can change the rules or block information. Therefore, since no single person controls a blockchain, it allows for new types of groups called DAOs, or decentralized autonomous organizations. These groups basically run themselves using computer programs and by everyone in a group voting on decisions. So far, we've learned that the blockchain is a shared record that's spread across many computers. But what happens once data is written? Can it be changed? One of the most powerful features of the blockchain is that it's permanent, meaning once data is recorded, it's impossible to change. Well, almost. That's because quantum computing could potentially pose a challenge to today's encryption in the future. Remember how each block contains the previous block's fingerprint or hash? This creates a great security feature. If you try to change data in any block, it changes that block's fingerprint. This immediately breaks the link to the next block, which still contains the original fingerprint it's expecting to see. To successfully change a past record, you'd need to recalculate every single block that came after it, and do this faster than new blocks are being added, across thousands of computers at the same time. The computing power alone to do this is mind-boggling. Think of it like a glass safe. You can see what's inside, and that represents the openness part. And once it's locked, it's sealed for good, and that represents the permanent part. Most public blockchains like Bitcoin and Ethereum are completely open. Anyone can view every transaction ever made using tools called blockchain explorers. It's like being able to see into every safe in the bank vault at the same time. It's also a little bit like that friend we all have on social media who just shares too much, except this time it's actually useful. Now, this doesn't mean you can see exactly who owns each wallet. Addresses are randomized, containing a string of letters and numbers, more like a numbered bank account rather than a set of names. So while anyone can see money moving around, the identity of the people involved often stays private unless they choose to reveal it. Some cryptos, called privacy coins like Monero, are built to keep your information much more secret. But this raises an interesting question. If there's no one boss and everyone has a say, how do all these computers agree on what's true? This brings us to one of the most interesting parts of blockchain, which is how the network reaches agreement. Think about it. If thousands of computers are maintaining the blockchain, how do they all agree on which transactions are real and which ones aren't? How do they stop someone from, say, spending the same money twice? It's a little bit like the rules of a game show where contestants vote on an outcome. Everyone must follow the same rules. In the blockchain, those rules are written directly into the code. Now, there are a few different ways that blockchains reach agreement, but here are the two most common ones. The first way is called proof of work, which is used by Bitcoin. Special participants called miners compete to solve tough math problems. The first one to solve the problem gets to add to the next block of transactions and usually gets rewarded with new crypto. Solving these problems takes serious computing power and electricity, which makes attacking the system too expensive to be worth it. And the second way is called proof of stake, which is now being used by Ethereum and many newer blockchains. Instead of solving problems, people are chosen based on how much crypto they're willing to lock up or stake temporarily as a deposit. If they try and cheat the system, they risk losing their deposit. This approach is faster and uses much less energy than proof of work. These methods are what make blockchains secure without needing a central authority. They make cheating, fraud, or manipulation nearly impossible without a huge amount of effort and cost. While secure, both systems have ongoing developments to address challenges like processing a high volume of transactions quickly. Now that we understand how blockchains work, let's compare them to older systems that they might one day replace. Let's look at how blockchain compares to traditional systems that we use every day. Traditional systems have one company or organization making the rules. Blockchains spread control among many computers. The rules are built into the code itself. In traditional systems, data can be changed, often without you knowing. But in a blockchain, data is permanent. Once recorded, it's extremely hard to change, if not impossible. Traditional systems often have a single source of data. If the computers go down, you lose access. But blockchains are spread across many computers, making them harder to shut down. Traditional systems are often private and hidden. Many blockchains are public and open, allowing anyone to check the data. And perhaps most importantly, in regards to trust, with traditional systems, you have to trust a company or organization. But with the blockchain, you trust the code and the math behind it. I mean, let's be honest, the math doesn't care about your feelings. It also doesn't have a CEO who might run away with your money. What blockchain really represents is a shift from trusting organizations to trusting code, shared agreement, and open networks. But why does any of this matter beyond crypto? Okay, we've covered a lot on what the blockchain is, but why do we need the blockchain? The blockchain has real-world implications that could make our lives so much better. Blockchain technology is already being used in a number of ways. These include tracking food from farm to table, helping to ensure it's both safe and real. Checking votes in elections, with the intention of making voting more secure and open. Managing digital identities, by giving people more control over their personal information. Improving ownership of items like music, art, real estate, and more. Wouldn't it be great if you went to buy a diamond and you could trace its entire journey, from the mine to your finger, confirming that it was ethically sourced. Or picture voting in an election where you could personally verify that your vote was counted correctly without revealing who you voted for. Yeah, that's right, no more "I voted" stickers required. These aren't just ideas, they're being built and tested right now. Blockchain is more than just a buzzword. It's a new foundation for how we record, share, and trust information in the digital world. So, are you curious about where the blockchain is headed next? Let me know in the comments below. If you enjoyed this video, please like and subscribe for more content. Thanks for watching.